The expression of wave function for a particle in one-dimensional box is given by psi is equal to a sine n pi x divided by L. L is length of the box. The expression contains a undetermined constant a. A can be determined through the process of normalization, and it requires the integration of square of wave function with respect to dx within the limit of length of the box, that is x is equal to 0 to x is equal to L, is equal to 1. The expression indicates that the probability of finding the particle inside the box must be equivalent to unity. It means particle must be somewhere inside the box. Now we will do the solution of this expression. X is equal to 0 to x is equal to L psi square. So we will put the value of psi, that is a sine n pi x divided by L square is equal to 1. Square of this quantity is x is equal to 0 to x is equal to L a square sine square n pi x divided by L is equal to 1. Okay, and there is a dx with respect to integration is going on. So x is equal to 0 to x is equal to L. This is the limit. A square being a constant quantity will go outside the integration, a square. Then sine square theta can be written in terms of 1 minus cos 2 theta divided by 2 into dx is equal to 1. Okay, or we can rewrite the wave expression as a square x is equal to 0 to x is equal to L after multiplication with dx minus, oh, there is a constant quantity too. Being a constant quantity, it will go outside the integration. Dx minus a square divided by 2. We are multiplying with each of these terms one by one. So a square divided by 2, integration from x is equal to 0 to x is equal to capital L. Okay. Into cos 2n pi x divided by L. Into dx is equal to 1. Okay, or we can write a square divided by 2 integration of dx will give x, putting the lower limit upper limit, minus a square by 2 integration of cos 2n pi x divided by L with respect to dx will give sine 2n pi x divided by L divided by 2n pi divided by L. After the integration we will get this quantity. Okay, putting the upper limit and lower limit. X is equal to 0 to x is equal to capital L is equal to 1. Okay, a square by 2. Now we are putting the upper limit and lower limit, that is L minus 0 minus a square divided by 2. The constant quantity is L divided by 2n pi. Okay, which will be multiplied with the constant quantity outside here, and the variable value, we will put the value of x 0 and L, that is upper limit and lower limit. So sine 2n pi L divided by L upper limit minus sine 2n pi lower limit is 0 divided by L. is equal to 1. Okay. So a square divided by 2 into L. This is the solution of first term. Second term, a square L divided by 4n pi. Then sine 2n pi, LL will cancel out each other. So sine 2n pi minus sine 0 is equal to 1. Since we know that the value of sine 2n pi, that is n pi, is always equivalent to 0 and sine 0 is 0, so the second term will become equivalent to 0. So we can write a square by 2 into L is equal to 1. Okay. Or we can rewrite again a square is equal to 2 divided by L, or we can write a is equal to square root of 2 divided by L. So the value of constant quantity is square root of 2 divided by L, and we can write the expression A is psi is equal to, that is the expression of wave function for a particle in 1D box, is equal to, instead of a we are putting the value, that is square root of 2 divided by L, where L is the length of the box, into sine n pi x divided by L. Okay, so this is the final expression after normalization of wave function. This is the expression of wave function for a particle in one dimension box of length L. This is the final equation. Okay, take it. We haven't taken any equation, so we can take it equation number 1 and the final expression.